Privilege escalation via registry autoruns. In this video, we're going to be exploring the process of identifying misconfigurations in Windows autoruns with regards to permissions and privileges. So quite similar to what we did in the previous video, with a little bit of a difference, and that primarily comes into play when we're dealing with autoruns specifically and their link or functionality with regards or in relation to the Windows registry. So before we actually get started with anything practical, we need to get an understanding of what a registry autorun is in Windows. So registry autoruns are a common vector for privilege escalation in Windows systems, and this particular technique involves exploiting registry keys that are used to configure programs or scripts to automatically run when certain events occur, such as, system startup, user login, or service initialization. And in this particular case, or in the case of autoruns themselves, Windows autorun again is fairly simple to understand. You may already know what it is. It's just a service or program that's configured to run automatically when certain events occur, typically on system startup, user logins, or service initialization. So as attackers, what we're trying to do is try and exploit the registry keys that are used to configure the autoruns. And as attackers or pen testers, we can leverage insecure configurations or weak permissions in these registry keys to execute malicious code with elevated privileges. So again, just delving a little bit deeper into autoruns, Windows uses specific registry keys to define which programs or scripts should automatically run under certain conditions. And the common autorun scenarios include, system startup. These are programs configured to start when the system boots. You then have user login, where, these are programs that run when a specific user logs in. And then service initialization. This is, these are the services that start with the system and potentially with elevated privileges. So in terms of privilege escalation via registry autoruns, this is the methodology that we, will typically use to exploit them for privilege escalation. So we start off by identifying a vulnerable registry autorun. So the attacker identifies registry keys that control autoruns and checks their permissions, and tools like access check or PowerUp can help locate insecure keys. Secondly, we move on to exploiting the weak permissions. So if the attacker has write access to a registry key, or for autoruns, they can modify the key's value to point to a malicious executable or script, and this executable will then run with the permissions of the original autorun process, often leading to privilege escalation. And then, of course, finally achieving privilege escalation. So when the system restarts or the target user logs in, the malicious code runs with elevated permissions, granting the attacker higher privileges or allowing them to perform unauthorized actions. There is obviously another technique or a variant of this, whereby if we, as the standard user account, again non-privileged, if we have the permission to create our own autoruns, then that can work as well, instead of again modifying an autorun service executable or program executable. But this will become clearer when we get into the lab demo. Now, in terms of the registry keys for the autoruns that I just pointed out, this is where they can typically be found. So you can see the autoruns for system startup are found under HKey local machine, software Microsoft Windows current version run. For the user logins, they're under current user, not local machine. And for Windows services, which can run with elevated privileges, those are typically found under HKey local machine system current control set services. So with that being said, this video has a lab associated with it, and it's going to be the lab just below this video. What I'm going to do is start up the lab environment, and I'll see you there in a couple of seconds. Now you can choose to go through the video first and then go through the lab, or vice versa. It's entirely up to you. But I'll pretty much be explaining this, or registry autoruns will become, you'll get to understand them a little bit better through the lab. So I'm going to fire up the lab, and I'll see you there in a couple of seconds. All right, so I'm in the lab environment, and as you can see, you'll be provided with access to the target machine IP address. And again, remember, in your case, this will be different, and I'm pretty sure you're aware of the fact that this will change every time you restart the lab. So do make sure to replace my IP with yours if you're following along within your own lab session and this video. But you'll also see that there's a little bit of a difference. Not only do we have the Kali machine and the attacker machine running Windows, we also have the target machine, which again is the same target system, just logged in as the user administrator. So on the attacker machine, we have access as the student user. If I open this up, you'll see that there. So the user account is student. And then in here in the target machine, we have RDP access via the administrator user. Now, we're not going to be using it, but the reason this is important is because of the fact that we're using autoruns, and autoruns again run when this user logs in or the system starts up. So we're going to use this to simulate the administrator user logging in. So we'll log out and then log back in and show you that again the autorun will run with the privileges of the user in question. The other thing that we notice if we go to the attacker machine is we can see that a service or a program called HFS HTTP file server is already running, which means this particular program or service is configured to run at system startup. Now, we don't know anything regarding it, but we can use this as a basis to learn more about autoruns. Now, on the target system, on the attacker machine, on the desktop, you're going to have the sysinternals suite of tools. And this, again, is a suite of tools that, again, allows you to, pretty much learn more or manage your Windows system. But we have an executable in there called autoruns. And again, this is not really related to the privilege escalation aspect or side of things, but we're just using it to understand a little bit more about autoruns before we start exploiting them. So I'm going to give this a few seconds to start up, and again, it'll become clear why we're doing this. So just going to give that a few seconds. All right, so you'll get a smart screen notification. We're just going to click on run. And I'm going to click on agree, and we want to navigate to the, actually we can just start off with the everything tab. So I'm just going to maximize this, and under everything, we're going to see the autoruns here. Just hold on, I think it's taking, there we are, it's currently scanning, but we should be able to see the HFS server here. So there we are. We can see that remember I mentioned the registry keys for autoruns in the slides. In this particular case, we can see the HFS HTTP server can be found on the HKLM software Microsoft Windows current version run, which means that this particular program or service, in this case it is a program, has been configured to run on system startup, okay? And that's very important to keep in mind. So if it was HKey current user, then it would be configured to run for the current user or for the user configured. And if it was HKey local machine system current control set services, then it would be a configuration for a Windows service. So we know that this is a program and it's been configured to run at system startup for all users. So that means that it will be executed with the privileges of all users when the system starts up. So in this particular case, you can actually right click on this, and you can go ahead and click on properties, for example. We'll give this a few seconds here. But there we are. You can find the actual path. We're just using this as an example. Now that we have done that, we can actually see whether we can make changes or whether we have right permissions as the student user to the registry HKLM software Microsoft Windows current version run. So I'm going to open up a PowerShell session here as the student user. So I'm currently in the attacker machine, and this is not a privileged session or a privileged user, but I'm just going to increase the font size as I've done previously, and we're going to say get, and I'm just going to type that in here. So just a moment. So there we are, get. And I'm going to say well, let's get the ACL, and I'm going to set the path as we'll say H key local machine, and we'll then say software Microsoft Windows current version run, and then I'm going to pipe this and just say format list, and remember HKey local machine software Microsoft Windows current version run. This particular registry key, if you remember, is again used to configure programs that are supposed to start on system startup, and they will run, or the program will run under the privileges of the user, or whatever user is on the system and logs in. So I'll just hit enter now, and we can see right over here that the owner is NT authority system, and the group NT authority system. We can see that the user student has full control, which means we can not only replace the executables for existing autoruns, but create our own. And in this particular case, we can use that as an example for this privilege escalation technique. But the student user can modify the registry, and we could, set an additional malicious executable path to the registry, or we can overwrite, hfs.exe or the regardé the HTTP file server. So one thing we could try, for example, or we need to try, is we need to actually verify whether we can actually modify the registry. So for example, if I just say regedit here, and we go HKey local machine, software Microsoft Windows, so software Microsoft, and we look for Windows. I'm just going to give this there we are, Windows current version, just to confirm this, and we're looking for run. 1 second, there we are. We can see there we are, we have the HFS HTTP server AutoRun. So what we can do is pretty much replace this particular executable. However, we might not have the permissions as the student user to modify this particular directory and consequently the executable. Alternatively, we can just point this to our own. So if we click on this, we can just change the actual value of the path here to our own path that contains our own executable, and we could save the malicious executable or MSF Venom payload, for example, on the student user's desktop. So that's an option there. Now, let's actually try one example. What if we wanted to modify the HTTP server or HFS executable with our own? Well, we can use get ACL again, and I can just say get ACL and see, we'll say under program files, and we're looking for HTTP server, I believe it's called. That might be incorrect, but then we'll just say format list. All right, so we can see right over here, based on this, that we only have, let's see, built-in users read and execute. So we cannot make changes to that particular executable or that folder for that particular program. And so what we could try and do is add a new registry with the attackers with our own, malicious executable. So In order to do this, we're just going to go into the registry editor here, and I'm just going to expand this a little bit. And now in here we have the HFS HTTP server, so we'll create a new one, and we're going to say new, and we're going to say string value, and we can call it whatever we want, but it's important that you keep the name in mind. So, you know, we can just call this something like, let's just call it hacker, something like that. And what I'm going to do now is, let's just go into PowerShell, and I'll go into my desktop, and I'm just going to create a new folder called tool. Okay, and this is where we're going to save that particular executable for our autorun. So now that we've created that folder, I'm now going to generate the malicious executable, and in this case it's going to be an MSF Venom payload. So I'm going to go into my Kali Linux system, and I'm going to open up a terminal. And what I'm going to do now is I'm just going to get my Kali Linux IP address. In your case, that'll be different. So just look for the IP associated with the interface Ethernet 1. And I'm now going to say MSF Venom payload Windows interpreter, and we're going to say reverse TCP. Lhost is going to be our Kali Linux IP. So I'm just going to paste that in there, and we can set lport as 4444, and the format is going to be exe, and we can just call it, you know, program.exe. all right, and this is what we'll be putting in the tools directory, or the tool directory on our desktop, and that's going to be the program that we configure to auto run or run automatically, and the name of the auto run is just going to be called hacker. So we'll modify that in a second. In the meantime, I'm now going to set up our handler. So I'm just going to say MSF console, and we'll use the exploit multi-handler. And I just want to get that running so that we don't have to do it. So I'll say use exploit multi-handler. This will be used to again receive our interpreter session. So we'll say specify the payload right over here, and it's going to be the one we used when generating the MSF or the payload with MSF Venom. So reverse TCP, show options, and I'm going to set lhost to my Kali Linux IP. The port is already configured as 4444, so that's fine, and we can just hit exploit. Hold on, let me just type that in correctly here, my bad. There we go, and I'm now just going to say exploit to start the handler. I'm now going to create a new tab. Sorry, let me just create a new tab here. And there we are, we have programs. So we now need to transfer this onto the target system or onto the attacker machine here. So I'm going to set up a web server with Python to host it. So Python simple HTTP server on port 80. Okay, so I'm going to start a web server on the Kali Linux system on port 80 to host our malicious executable or our MSF Venom payload. And now that that's done, we can actually just download it onto the attacker system into the tool directory here. So I'm going to go into the tool directory, and I'm now going to say with PowerShell, so we can just say IWR, use basic parsing. The URI is going to be the actual URL of the web server running on the Kali Linux system. So I'm just gonna get my Kali Linux IP 10.10.22.2. So there we are, and we're gonna say the URI, let me type that in, is going to be HTTP, and I'm going to paste that in there, and the name of the executable is program.exe, and I'm now going to say I want to save it as so the out file is going to be we are going to say the out file is just again you know, we'll say we want to save it under C, users and student and desktop, and under tool and program.exe, and I'll close that single quote there, hit enter. And if we check it now, we have program.exe in here. So we now need to modify the registry key that we created, the autorun, and specify the path. So in this particular case, we'll just go into the registry editor, open up Hacker, and in here I'm just going to specify the path to the executable for the autorun. So I'll just say users, C users, student. Let me make sure that is in uppercase. C users, student, and that is stored on the desktop, and it's stored in a folder called tool, and the name of the executable is program.exe. Okay, there we go. So we've configured our autorun here. And yeah, that looks about right. So now there's two options. In a realistic sense, if you had used this particular privilege escalation technique, you could either wait for the user to reboot the system or to log in again. Now what we're going to do is we're going to simulate the administrator again logging in. So we're going to go into the target machine tab, and I'm just going to sign out right over here. Or alternatively, we can just open up PowerShell and say, we can just say, if I wanted, we can just say shutdown, and we'll just say, yeah, we can just say shutdown L. So that's going to sign the user out there, and we can then click on reconnect, and that will re-authenticate as the administrator user, and our autorun that we created should run with administrative privileges. And if we check our listener right over here, there we are, we get the interpreter session once the autorun is executed. And if I now say get use ID, we can see we are now running as the administrator, or we have obtained or elevated our privileges through a registry autorun. So as I've pointed out, just to summarize, that was fairly simple, but in essence, there were two techniques or two options that we could have leveraged. Firstly, if we had full control over, or the ability to make changes to existing autorun program directories and executables, we could have replaced one of these autorun executables with our own, but in this case that wasn't the case. So we checked to see whether we have the permissions to create new autoruns, and indeed we did. And we pretty much just created an autorun that executes our MSF Venom payload for every user when they log in, or when the system reboots and then they log in. So that means that if we were to log out if we were to log out and log back in as the student user, then we would get an interpreter session with student privileges, or as the student account. And likewise, we just simulated it with the administrator. So you'd have to wait realistically if you're looking at this from a realistic perspective, you'd have to wait for the administrator to log in and for the autorun to run. So with that being said, that brings us to the end of the practical demonstration section of this video.